One important skill in calculus is to be able to take expressions involving reciprocals of a variable, powers of that variable, or radicals of that variable, and rewriting them in exponential notation. Here's an example where I have a bunch of terms, in this case 4 over x to the fifth, and I'd like to rewrite this first term as a number times a power of x. Similarly, here I have 2 divided by 3x. I'd like to write it as some number, a coefficient, times a power of x. 4 times the cube root of x squared, I'd like to rewrite that as some number, probably I'm guessing 4, times the right power of x. And in this one, I'm taking 8 over x, dividing them first, and then taking their square root. And again, I'd like to have some coefficient times the power of x. I think the first thing that would help is if you separate the coefficient from the expression involving the variable. So in the very first term, I see 4 times 1 over x to the fifth. I'm visually separating the fraction. It's a coefficient, in this case 4, and I'm multiplying it by the reciprocal of x to the fifth. In the next one, it's minus 2/3, and I'm multiplying that by 1 over x. Not much to do in the third term. It's 4 times the cube root of x squared. And then in this one here, I'm dividing under the radical, so I can think of that as the square root of 8 divided by the square root of x, and separate those in a fashion similar to the previous terms. But notice that the coefficient will be square root of 8, and then it's 1 over the square root of x. Once I've really thought about what the coefficients are, I can now tackle the problem of what to rewrite each variable expression as, what power of x I should write it as. One thing to keep in mind is if I have reciprocals, those become negative exponents. So the first term is 4 times x to the minus fifth. The next term is minus 2/3 times x to the minus 1. Radical expressions such as cube roots can be written as rational exponents. A cubed root wants to be cubed to bring it back up to its full power, and that's a reminder that the exponent you want to use should involve 1/3 in the exponent. It's also being squared under the radical, so we want to retain the fact that it's being squared, and that will mean that my exponent will be x to the 2/3. Finally, in the last one, it's minus square root of 8, and then it's times x. It's in the denominator, it's a reciprocal, so I'll have a negative exponent, and then the 1/2 indicates the square root. So we have x to the minus 1 over 2.